Mr. Haresh Khoobchandani.
Good morning, Bangalore. All right, welcome to AU India. How was that opening? Football. So if you guys know me, you will realize that football has been my first love, and I say has in the past tense, not because I'm married, but because I fell in love with something else. So I get to be back at AU India and to kick off AU India once more, where I did the same thing last year. So I'm really privileged to be here. And Theo, this is for you. All right. I didn't mess that up. Lucky. It's a real honor and a pleasure to be back in India, to be back in Bangalore, one of my favorite cities, to talk a little bit about AU, to talk a little bit about Autodesk and where we're heading. Now, in the last 12 months, I've been in the company now for slightly above 12 months. And in the last 12 months, a lot has happened. And a lot has happened around people talking about technology-driven disruption, technology-driven innovation, and what does that do for the future? A lot of conversations now center around technology at the heart of it. So let's talk a little bit about the future and try to emphasize what does that really mean. So an economist, if you speak to an economist might say automation is going to take all your jobs. And a journalist might point you to a very bleak headline about a bleak future. Now, a technologist, on the other hand, might tell you something else. They might say, technology is going to save us. I personally believe the future is for us to make. It's for you to make, for me to make. It's for all of us to come together to decide how we want to create a different future. Now, I know the powerful impact your work has on the world, has on India. I've met so many partners. In fact, I met one customer yesterday, and he was talking about all the amazing things he's doing, and at the heart of it was driven by our software. And in fact, I told him, Bimal, I don't know whether you're here, but I told him he should be up here talking about and doing the keynote. And it's pretty impressive when you think about, despite the power of technology that's out there, changing world, changing lives, there are opposing forces that are pulling us in different directions. The opposing forces of abundance and scarcity. Now, on the one hand, we worry that the overpopulation of the world is inevitable. In a world with more automation, where so much more is needed, when you think about the growth that we're seeing globally. But at the same time, we fear there will be less jobs and less of our planet's scarce resources, and we know the impact this is had on our planet. Now, as much as we accept the inevitability of more, we still struggle to face up to the reality of less. So what do we know about the future with any certainty? Here's the thing. We know that the population is growing globally, and not growing slowly, it's growing really quickly. And that the middle class is growing quickly as well. We know that the last year, we globally reached a tipping point where for the first time, over half of the world's population are now considered middle class. Now, I know many of you in the audience here will have different definitions of the term middle class. Now, whatever your definition, what's clear is the fact that 4 billion people today are prosperous enough to be protected from poverty, and that's enormously great news, and we should be thankful for that. But we also know that with this increasing prosperity comes increasing demand for motorways, for mobile phones, for education, for energy, for housing, for hospitals. All of this needs to be developed. So more is inevitable. So how can we all make what we need, but do so responsibly with less negative impact? Less negative impact on the planet, less negative impact on people. In order to solve this fundamental capacity issue, we're going to have to fundamentally rethink the way we make things, all of us collectively as a community. And addressing the inevitability of having to do more, along with the reality of doing it with less negative impact, is what we define as a massive design challenge. But addressing a challenge of such enormity and complexity is also the biggest design opportunity we've ever had. Now, our technology helps you with design challenges every single day. And I've had the privilege of meeting a lot of customers to understand what they do, a lot of partners to understand what they do every day with our software. Automating how things are designed in the digital world and made in the physical world, which is why we believe that along with the inevitability of more and the reality of less is the opportunity of better, the opportunity for a more balanced, more sustainable, more equitable world. Better for growing the middle class, but also for those still in poverty. So let's explore a couple of different scenarios, a couple of different cases of great work happening to take advantage of the opportunity we see and the challenges we want to solve. So design challenges don't get more massive than the one that faced Phoebe Goodwin, who is an architect for the UNHCR, the United Nations High Commission for Refugees. Now, imagine for a second that you have to build a city for 600,000 people. And you might be wondering, 600,000 people is not much, but you only have 6 months to do it. Now, that was the size of Phoebe's challenge. And the city in question here is Cox's Bazar in Bangladesh. Now, what was happening, Cox's Bazar grew quickly in Myanmar as Rohingya refugees fled persecution and poured into the refugee camp in the year 2017. In the last 4 months of the year, that refugee camp grew 7-fold. And in that year, the community grew to over 500,000 people. Now, to put that in perspective, that's about the size of Mangalore, which is a city not very far from Bangalore. The growing number of displaced people placed a growing burden on the site's infrastructure, which is why the UNHCR had to step in and why Phoebe had to get involved. Now, by the time she arrived, the hilly site had already grown substantially and organically. Spontaneous settlements were causing problems with existing services, sanitation, and safety. Now, the refugees also needed to burn wood in order to cook, which led to another challenge, deforestation of the surrounding area, which made it vulnerable to mudslides, especially in the monsoon season. And I think all of us are familiar with the monsoon season in India, which was only 6 months away. So Phoebe needed to plan how to build a more resilient community, but she had to do that quickly, which is a massive challenge for her. She started to plan the changes on the site. Changes needed where shelters should be moved, where latrines, roads, bridges, and paths should be sited to keep people safe. And this had massive implications in terms of people's lives. Planning efforts on the site often begin on paper, but Phoebe knew she needed a better way to gain insights because we all know, after all, a flat piece of paper is not the best way to solve problems of a hilly site. So she turned to one of our products, AEC Collection. Many of you are familiar with that, which we donated. But she also turned around to available terrain data. And then she used a partner of ours called Microdesk. And what Microdesk did was, they trained UNHCR team in the benefits of using 3D data in Civil 3D. So Phoebe now, as a result of the software and the simulation, could now use a flood simulation module to analyze where flooding and landslides could be expected. She could automatically now generate floodplain and floodway maps. Now, why was this important? Because this was enough to persuade the local government of the need to bring in heavy equipment, heavy machinery, and build substantial earthworks. So Phoebe's digital work had a tangible, physical impact. The UNHCR team, as a result, was able to remodel critically at-risk areas and move over 100,000 shelters to higher and more stable ground. The inevitable monsoons came, and so did more people, but there was less negative impact on the site and its occupants. Phoebe was able to build a city for over 500,000 people in a matter of months instead of years, and seized the opportunity to better plan for the monsoon season because of the use of simulation software. Now, that resulted in better insights, which is critical, better sited shelters, a better community, but more than anything else, it resulted in lives being saved rather than being washed away.
Challenging the design problems that we are faced with and that we do have to resolve in difficult circumstances, crazy time constraints, and limited budgets. Regardless of the scale or complexity of the design problems that we face, Civil 3D enables us to make anything we need.
So, if simulation can help build a more resilient environment for 600,000 people, what can it do for the rest of us collectively, for those of us who are making everyday decisions in the everyday companies that we work for? It doesn't get much more down to earth than cement. And we all know a lot of cement is being used in India in its development and its building. Now, cement is a key ingredient in concrete. Now, concrete is used everywhere, in buildings, bridges, drains, and dams. I want to introduce to you Claudius Peters, which is a German company that makes the heavy equipment to make cement. Now, they've been making grinding mills, conveyors, and coolers for over a century. So they're an old company established. But now they're exploring how, by making their industrial machineries more efficient, they can reduce their customers' money, they can save their customers' money, and more importantly, reduce the negative impact of cement production. And why is this so important? What's the big deal with cement? Here's the thing. As harmless as cement seems, it's a big emitter of greenhouse gas. In fact, cement production accounts for 8% of total greenhouse gas emissions. But here's the opportunity. 50% of that negative impact happens during the production process. So any improvements to its production process would have a big impact. Claudius Peters knew that, so they got to work. They started by looking at how it could evolve things. Now, they started with this thing called the Clinker Coolers, as I'm learning it as well. These things help move 13,000 tons of clinker a day, massive amounts. Now, clinker is what you get when you grind limestone and clay, and then you heat this in a mixture of 1,500 degrees Celsius. We wouldn't want to go anywhere close to that. Super hot. And these are the pans that hold the clinker after it leaves the furnace and enters the cooler. Now, before it's ground into cement, each cooler has 60 or more of these pans, each of which are cast in a foundry and bolted together on a series of conveyor lanes that move through the cooler. Now, the engineers at Claudius Peters did a lot of work. They'd already optimized the part several times to remove as much excess material as possible. They were confident that the design was efficient, was the right and the best design they had for the task they had. They had used Inventor's simulation capabilities to validate that their design would perform as expected, that it would withstand the axial load of the conveyor system. Now, meet their chief digital officer, Thomas Nagel. Now, Thomas was wondering if there was a better way to do this. So he was wondering whether generative design could help them optimize the part further. So with the engineer's best design set as a baseline, he set up a workshop together with Autodesk to explore what could be achieved. And after 4 hours, not 1 day, not 4 months, not 4 years, after 4 hours, the team had their first results. And this is what it looked like. So Thomas called it the alien part, because in place of the engineer's angular design was a form that flowed in unexpected ways. It wasn't just a form that flowed in unexpected ways. It was also the way it looked was unexpected, but so was its performance. This part was 40% lighter, and as a result, the engineers were suspicious. They said, it can't be the case. So what did they do? They went back to Inventor and ran more simulations to test the designer's performance, the design's performance. And guess what they found? They realized, and they were astonished to find out that it outperformed their own design. Their work redesigning the part digitally had a positive impact on the physical part. But there was also another unexpected outcome. What generative design did was it produced an organic form that could only be made, unfortunately, using industrial additive techniques. 3D printing in metal. And this was just too costly. So what did the engineers have to do? They had to go figure out a different manufacturing strategy. The team needed to reverse engineer the part so it could be made using more traditional techniques. Now, going backward and forwards in Inventor, adapting its design, simulating its performance, they soon came up with a solution that could be welded together from laser-cut steel. And this is what they came up with. A new part which was 25% lighter, faster to make, and less expensive. Now, each of the part you see here would be 100 euros cheaper to make. Not a significant amount, but these savings stack up given the size of the project. There are 60 parts in each cooler. Plus, they are substantially lighter, which means Claudius Peters would also benefit substantially on lower shipping costs. Now, evolving the performance of this pen is one small part in the investment that Claudius Peters is making in improving thermal efficiency of their coolers. Coolers that are more thermally efficient, burn less fuel means less significant greenhouse gas emissions. And essentially, when they did the math, it was over 50,000 less. To put things in context, that's the equivalent of taking over 12,000 cars off the road for each cooler. So significant impact in terms of using technology to improve the part. Now, this thing might just be one small part of the puzzle, but by exploring how it could be designed better, Thomas and his team at Claudius Peters found an opportunity to make it better. The part now can be made locally and more easily. The part uses less materials, less energy, and has a less negative impact on the planet. Simulation software helped Claudius Peters gain insights into the performance of their new coolers, but it was generative design that opened up the opportunity for them to make things better and in better ways. Now, as we saw, simulation is a powerful tool that can provide valuable insights, and I think all of us would agree with that. But when you run a simulation, you also discover the insights into a design's performance, insights that are critical for the success of any project. The problem, as Claudius Peters will tell you, is that it's extremely compute intensive for a simulation to run the way it does. So in fact, every time you double the resolution of a simulation to increase its accuracy, the required computing power increases by a factor of 8, which is huge. But in the time it would take you to simulate one design option on one computer, you could actually simulate 100 different options on 100 cloud processes. So the cloud provides so much compute capacity that you can now flip design and simulation around. Not just simulating after design, not just simulating to validate your design, but simulate to discover your design. With generative design, you just need to describe the problems, the goals, the constraints, and the forces at play. Using cloud computing, our technology can help you discover designs you would never imagine, as you saw in the Claudius Peters example. But big data and cloud computing are now enabling us to have a positive, powerful, and growth impact. But to understand the power of the cloud and simulation, look no further than one little city called Bangalore, right here. Now, like myself, I'm sure many of you have gone through or came here today through Terminal 1 of Bangalore International Airport. The only terminal available today. Terminal was built with the goal of catering to 20 million passengers when it was first designed. And guess what? About 5 years ago, in 2014, the Bangalore International Airport went above capacity and served more than 28 million passengers. Now, the good news is a new terminal is on the way, much bigger and much better. And I'm sure all of us would agree we're all looking forward to that terminal. It's going to be 1.2 million square meters, 3 times the size of the current terminal, and include a new runway and 2 metro stations. Now, phase 1 of the airport, which won't include the metro stations and the second runway, will be ready and is projected to open to the public on 31st March 2021 and will serve an additional 25 million passengers per year. All right? Much needed in this growing city. Now, here's the thing. when the airport says Terminal 2 is going to open on 31st March 2021, they actually mean it, which means there is no room for delay. There's absolutely no way they're going to allow for any delay to take place, because for each day delayed, they incur a heavy penalty. They incur 1% of the total estimated cost per each day delayed. Now, the total estimated cost of the project is $1.2 billion US. So you can do the math to understand that, and you can understand that the stakes are high. So how can the planning and design team ensure that they deliver an airport up to travelers' expectations, but do it on time and on budget? So the design and planning team, there was a small team of just 4 people, and knew from the beginning that the only way that they could do this was if they used BIM 360. Now, BIM, or Building Information Modeling, is the only process that enables documents, management, coordination, and simulation during the entire life cycle of project, anytime, anywhere. So when they put out the RFP, they did something that's pretty unique in India, and in fact, pretty pioneering in the market. They mandated BIM 360. Now, while there's still a long way to go, here's where the project is today. The project's going on budget and on schedule, and the design and planning team don't anticipate any slips. In fact, they have reasons to feel very confident. Just to give you a context, in the last 8 months, 28,000 documents were submitted for approval by the contractors. That works out to 3,500 documents per month, 175 per day. By the end of next year, the design and planning team expects to cross 25,000 drawings. Now, what does that really mean? What it means is they are now able to digitally build the airport before it's built physically and eliminate any inefficiencies that arise during construction itself that could potentially derail budget and execution. World-class development happening in the heart of Bangalore. But not only are contractors faster, the airport team is also more efficient. Instead of 12 days, the team now takes 4 days to respond to RFI, request for information, even though their team is now 25% smaller. As a result, they are much quicker at approving projects. Now, this is the power of cloud and real-time collaboration and coordination between all the parties involved in the process of constructing the airport. Designing and delivering the project on time is not only reason why the International Bangalore Airport is using BIM 360. There are other reasons. The team is also using BIM to future-proof the management of the new terminal. In the current terminal, existing terminal, one of the biggest challenges the airport faces is the lack of ownership of the data, which makes changing facility management very hard and time-consuming. But in Terminal 2, this problem won't exist, because BIM supports an application used by all contractors called COBE. And with that, once the airport is up and running, the team will be able to transfer facilities management tasks by connecting BIM data generated during design and construction phases to building operations. The airport will now own the data and be ready to work with anyone at any time. Now, thanks to BIM, the Bangalore International Airport has insights throughout the entire life cycle of the project, something they never had before that otherwise wouldn't have. It's helping the team to be more productive. It's helping all parties to communicate, to coordinate, and collaborate from the beginning and across the entire construction project. And it's making costs and timelines more predictable. So predictable that the Bangalore International Airport are certain that 31st March 2021, and not a single day later, they will be up and running and serving the world. This is a great example of what's possible with BIM amid India's ambition to build necessary infrastructure and housing, and something I'm really proud of to see happen, and I'm actually quite excited to come to the new terminal. Now, the opportunity the cloud gives us all isn't just about moving computers moving computers out of our premises. It's more than that. It offers a capacity to converge the way we design and make things, as you've seen. Today, the way something could be starting to drive, the way something could be made is starting to drive how it should be designed. And tomorrow, we want to give you a clear line of sight from design to make, all the way from part to production. So we can give you insight into the different ways that your designs could be made, and insight into the material and energy costs embodied in each of your design opportunities. But as well as give you the capacity to converge the way that you make and design things, just imagine if we could give you the capacity to connect them too. If we could use the cloud to connect the design challenges you face, think of the insights that we could generate and the difference we could make. If we could see supply and demand for all the raw materials that go into all of your projects, just imagine how much more balanced we could make the world. If we could help construction become more predictable, like manufacturing, and manufacturing more flexible, like construction, we could help you become more efficient and less wasteful, an outcome that all of us are pursuing towards. By converging and connecting what we design and make, the cloud gives us the capacity we require to better imagine and better see what we're really trying to accomplish. Now, Phoebe saw the opportunity of better planning and faster execution to save lives. Claudius Peter saw the opportunity to design better things with less negative impact, less material, and less energy. The Bangalore International Airport saw the opportunity to plan and collaborate better to deliver the project on time, which had material impact. My question to all of you is, what opportunity do you see? And I encourage you to think about this. Imagine the impact you could have if you had the capacity to do what you've done before, but only better. Now, the cloud gives us that capacity to better imagine what we're really trying to accomplish. And it's giving us the opportunity to make the world more balanced, more sustainable, and more equitable. We want to create a better world, and we get to create a better India. Thank you very much. Enjoy the rest of AU, everyone.